I bought an abandoned bumper car to restore. Earlier I showed how we repaired the plastics, fixed damaged parts, replaced the chrome, and did something even more important. We gave it a complete paint restoration, painting it with a chameleon paint that changes color. Now, the most important part was missing the entire electrical system, because without it, the car wouldn't work. I began with the easiest task, fixing all 4 lights, 2 in front and 2 in back. The original bulbs were still in place, but obviously they didn't work. The lamp holders were also pretty damaged, but I was able to save them just by sanding them a little bit. I replaced the original lights with LED lights. In the front, I put 2 white lights, and in the back, 2 orange lights. All the original wiring was in terrible condition, so I removed it and replaced it with new IMSE plastic wires. I tested everything and it looked great, so I left it. But the main thing is, this car originally had a system that took power from the floor and the ceiling of the track, but I wanted to adapt it to use a battery. First, I identified where power entered the motor to use those wires to connect it to my battery. After a quick test and seeing that the motor worked, I continued with the throttle and the other things. Originally, I thought about using a brushed motor controller, but it didn't work very well. So I just printed a pretty basic throttle that basically pressed a switch. So this switch activated a motorcycle relay that allowed the energy to go directly to the motor, and that's it. Basic, but effective. The motor had a problem. Over time, all the rubber that touched the floor wore off. I remembered I had a skateboard wheel to replace it, and it was the same diameter. To soften it, I put it in the oven at 150 degrees for 30 minutes. Using force and leverage, I got it onto the motor and glued it with a polyurethane adhesive to keep it in place. I also did some maintenance on the motor, thoroughly cleaning it with naphtha to remove years of grease residue. I thoroughly greased it with lithium grease to ensure optimal performance. This motor has a pretty interesting gear system that adds torque, and the wheel is attached to the motor itself in a very clever way. Now comes what I think was the part. I wanted to turn this little car into a drift cart or a drifting car. So I started researching how they worked. It has a very interesting system. They have some swivel wheels at the back set at an angle, and this same angle makes it so they can't turn and stay straight. But they have a lever that changes that tilt and now allows them to turn freely, thus allowing drifting. My self-checker had a rear axle with 2 wheels, which I put to use. First, I separated it from the little car, bought 2 swivel wheels, and welded them in that same spot, but at the angle I mentioned before. To make it adjustable, I welded 2 hinges to the axle base and screwed them directly to the car. This way, we already have the movement we needed. All that remained was installing the lever. I used a piece of structural iron to put it in place. I made a hole in the bumper car for it to pass through, so it looked like it was coming out of the floor. I bent it slightly to make it easier to grab. The system seems to work well at first glance. It looked just like the others I'd seen, so I really trusted it. With everything ready, all I could do was cross my fingers and test it. We took it to a park, and no, it didn't turn out as we expected. We took it to a park, and we didn't expect it. I'm an electric car. I was remembering that. I'm an electric car. I don't go very fast. I don't go very far. The problem was basically the most important thing. The motor was terribly inefficient. It was a brushed motor, very heavy, and consumed a lot. It drained my 100-watt battery in under 10 minutes and was extremely fast. I had faith in the motor, but I was very disappointed. Clearly, I didn't have to change. First, I cut the old motor mount, which was tough, but after some cutting and hammering, I got the motor out. The motor I chose would be this one. It's a 350-watt motor taken from a Segway scooter. It may look small, but this motor produces a lot of power. In the little car, I used 2 pieces of 1-inch angle iron to make the new mount, and I welded them to the base where the old motor was. This is a 360-degree rotating base that's connected directly to the steering wheel. I made 2 slots in the iron pieces to place the motor and fixed it in that spot. I enlarged the original cable hole to run the wires, as there were previously 2 wires, but now I needed 3 for the motor and 5 for the sensor hull. Because this is a brushless motor, I connected all the wires to a controller that I hid inside my little boat. And in that same place, I put a 12V transformer for the lights, a voltage display, and a power switch. All of that is under the acrylic cover that I made for it. Almost finished. I put the new throttle in place, and now it's time to cross my fingers and hope it works well. In this case, we went to test it in a parking lot, and now the performance was spectacular. It wasn't because it was very fast, as that was never my goal. But it did get good acceleration, and I loved how it worked. At first, it was pretty hard to learn how to use it. When you lift the lever, it basically goes out of control, but we got the hang of it. Though we haven't managed to circle the bottle we set up yet, at least for now. I'm going to improve 2 things. The first thing is to add 2 small swivel wheels in the front, because when you turn too hard, sometimes it would tilt and the tip would hit the floor. Also, the 2 rear wheels we added had no brakes. One of them just couldn't handle the friction. If you have any recommendations on how to use them, let me know in the comments. Thanks for watching. See you next time. Bye.